All right, guys, another day, another video. So in the last video, we created our Vapor server tied to our Postgres backend. And in this video, we're going to tie everything together so that the front-end SwiftUI client is communicating with the Vapor Web API service. So if you take a look at this simulator application, this is actually the final finished product for this video. So all of the pathing and the string content that you see here is being loaded off of the Vapor server. And this is what we're going to build. So to get started, we are going to do some refactoring of the API service and the other related services. So the first thing that I want to do is I want to get a root path to our root domain. So we can just reuse this instead of hard coding this all over the place. And this data that I'm about to create, we're going to be passing down to the initializers of our APIs. The other thing that I want to create is encoder and decoder instances so that we don't have a bunch of these, because we're going to be making a lot of network calls. So I don't want to keep instantiating these guys over and over again, sort of all over the place. So I want to instantiate them once and pass them down. And then the other thing that I want to do is I want to get rid of these static members, partly because I just don't like the inflexibility of using static, but also because we need to pass these fields down, and having them be static members makes that difficult. So what I mean by that is we're going to do this. We're going to create a singleton instance of our API service. Okay, and in order to do that, we need to do that successfully, we need to make our initializer, our constructor, private, so that nobody outside of this class can access it and thereby instantiate another instance of the API service. So we're only ever going to have one. Obviously, this guy can access it because it's still internal to the class. So we're going to go off of this singleton instance. And therefore, by doing that, we no longer need to have these guys as static anymore. But we do need to make one additional set of changes, which I'll show you in a moment. So what I'm doing here, and let me write this all out so that it makes more sense when you see the whole thing. So just give me a moment here. So what am I trying to do here? So first of all, I'm making this lazy, and I'm going to do this to all of these guys eventually, but for now we'll start with this guy. So I'm making this lazy so that this closure will only run upon the first call. So we don't have to keep, we don't have to make instances of any of these APIs until they're actually needed. So they won't load, they won't initialize upon load like they were before. They'll just initialize the first time they're actually needed. So that's what the lazy is about. Now, the private stuff, in the case of private set, I am making it impossible to change this field, this property, outside of this class. So I want to be the only one, API service is the only one that can actually initialize this person property. So that's what I'm doing here. Now, how am I doing the initialization? Well, I'm going to have a private member, as you can see here, and I'm going to check that private member has an instance or not. If it does have an instance, then I'm just going to return it. But if it doesn't, then I'm going to initialize it. And then I'm going to return it. So this way, and I'll show you why this is safe in a moment. But this way, it only ever gets initialized once, and it only ever gets initialized when it's actually needed. So it's possible that depending on what screen you are in a larger app, some of these may not even be initialized ever during the session. And that's great because then, you get to save some of the user's memory. So this is safe because of this logic here, which will basically, make it impossible for this to be nil. So that's what we're going to start doing on the rest of these once we get to that point. But for now, I just want to update this guy just to get started, right? So what I'm going to do is, in order to make sure that if you are an API, you are following certain rules and you have certain capabilities built in, I'm going to create a protocol that all of these APIs are eventually going to inherit from. And the protocol is just going to have these fields up here that I created. So I just want to make sure that everybody is going by the same set of fields in terms of availability. If you're coming from a different language, a protocol is basically the same thing as an interface. So on TypeScript, C#, Java, it's basically the same thing as an interface. So the first guy we want to update, because that's the one we just refactored, is going to be this guy. So we're going to make this inherit from the base API. I'm just going to copy and paste these. So in order to get some data or to populate these fields, like I said before, I'm going to get them from the constructor. Okay, so we're initializing from outside. All right. Sorry about that. So now we shouldn't have a problem. Now, of course, we want to get rid of this hard-coded data, but I'm not going to do it just yet because we don't have an authentication system in the backend built out yet. I wanted to get kind of the root functionality working in the previous video first before adding the complexity of JWT and security and all of that stuff. So temporarily, we're just going to leave this in here so that this call will still work. And we're going to update this guy instead and make it, a network call to our web API. But before we do that, before I forget, I need to pass in our data. So now we have our fields in here. Should be good to go there. And then if you look at this call, it is being made inside of our store, our global state object for the entire application. So it's being called here in order to populate the list of people that the current user is actually following. So like I said, we'll leave this alone, but we'll update this guy to make an actual network call to our web API. So the first thing that I want to do is I want to get the URL. So we had already created that. So we're counting on this to be populated by the interface. I mean the initializer. So then if we go here, this is the Vapor server. You can see that the user controller that has all the routes for everything related to user. A sub URL off of the domain is going to be users, and we have our get following function there. So that's why I've appended /users. And then we're going to take the URLSession shared data task. Going to pass that in there. So the first thing that we need to check is that there's actual data in here. So if you're not familiar, guard just is a way to check that whatever data you're interested in or field you're interested in is non-nil. So in this case, we're checking if it is nil, then we're going to do something down here and then exit. So we always have to return. We can do whatever we want prior, but we ultimately have to return. And then if it is not nil, then this will be set to whatever the data is, and then we'll be able to use it down here. So in this case, I'm just going to print out that get following data is nil, and then I'm going to return out. I'm going to exit out. Now, assuming it is not nil, I'm going to do a catch statement, and the reason why I'm going to do a do catch statement or a try catch statement is because the decoding is throwable. Okay. And we wouldn't have to do a do catch, which again is like a try catch in other languages, if we added throws in here to indicate to any callers that this potentially throws and therefore needs a try prefixed in front of it. But we don't have that, and there's no real reason that we have to. So I'm going to not do that, and I'm just going to do a try catch. And then if this fails, I'm going to indicate that trying to decode the data has failed. And assuming it went through, we'll get the list of people. From the decode attempt. Now, in this case, this is indicative of the user type, in this case, an array of users, but the type as opposed to an instance, which is what this indicates. So now that we have this, we're missing something. So what we're missing is, first of all, we're not going to do a return because this is an asynchronous call. So this call right here isn't going to actually work, right? Because we don't know in an asynchronous call when this thing is actually going to complete and the data inside of it going to become ready to use. So we're not going to do it this way. But the other thing that we're missing is we're missing .resume, because if you don't have resume on this async call, then it's going to basically it's never going to come back, basically. So always remember to add this. And what we're going to do here is we're going to put in a callback that is escaping. Let me just write this out first. Nope. So we're going to have a callback, a closure, which takes a list of users. So it's going to take this, in other words, and it's going to return nothing, because this callback, the actual closure, is going to be submitted by the caller of this getFollowing function. So then we're going to mark this escaping, because this callback the lifetime of this callback may exceed the lifetime of this actual function. So we're indicating to allow this to basically stay alive is what we're doing by adding escaping. And then after we get the data, or after we decode the data, we're going to pass our users that we got back. This allows me not to use the parameter name. And then in here, we're going to get rid of this. And we're going to create our, we're going to create our we're going to create our closure, and then we're going to pass the closure into this member, which is right over here. This is because we did not update. So remember, we switched to a singleton. So we just need to update for that. All right. So Swift does not have a garbage collector. Swift has something called ARC. So ARC stands for automatic reference counting. Basically, it's a secondary service that goes about and tries to clean up memory for objects that no longer have any references to them. So just to be clear, this only applies to object instances. It does not apply to structs, value types, because they're always passed by copy. But anything that has a reference to it, this will apply. So the reason why this is giving this error is because in this case, we are living inside of an instance of store, right? And in this instance of store, we have a closure that is referencing the instance of store via the self keyword. Now, the reason why this is a problem is because closures are actually also reference types. They're object instances. So what we have here is one object pointing to an instance of another object, the store object, and then the store object pointing to this instance of the closure object, because this closure is defined inside as a member of this store type, right? So what we need to do is we need to basically tell the compiler, which one is allowed to, I'm going to take care of this in a second, which one is allowed to be deallocated first. Because if you don't tell it, then it will not deallocate either of them, because it is afraid that basically, one or the other is still running. So by indicating this, you are allowing self, meaning the instance of store, to be deallocated first, which will allow this thing to run. But the only thing is, you need to check that the self is non-nil, because by allowing weak self, we are allowing this to be deallocated, which means that self could be nil, and then if you try to use self, it could blow up. So that's what's going on there. Now, what is this? All right, sorry about that. So this just means that before I can call into self, I need to make sure that everything that has to be initialized is initialized. So that's what this is about. And then I can call into our function. Let's see what this error is. All right, so we come back here. So now, in order to make this correct, we have to do basically the same thing here, right? Because this is a closure, as indicated by the signature. Just going to use the same one. Now, you might be wondering, well, what if this thing gets deallocated before this comes back, right? Well, in that case, then we don't really have to worry even if this never happens, because that just means we no longer have an instance of our main state object for the entire app. So that means either the app was closed or, it crashed or something like that. Either way, this has no value if this is nil. So we don't need to worry about that. Although, if you spotted that as a potential issue, it's still a good thing just to, that you're thinking about those types of things. So we're basically trying to do the same thing here. We're taking the decoder from our own self. If self is deinitialized or dereferenced, then this thing will not run. In this case, I guess you could say it could be an issue, but again, because this is so important to the workings of the entire application. If in the particular instance we're talking about the user API, if this thing was deinitialized, either something catastrophic happened in the app, or the app is now shut down, so it doesn't affect anything. So let's just run this to make sure everything's working. Okay, so to get our tab screen, we have to update the current screen. Yeah. So this is all coming in from the database right now, just to be clear. And if I were to, we're going to make this change for the blue warning in just a minute. So if I were to null that out, you can see nothing is loading, because again, all of this data is coming from the back end. So if I undo this, what I need to add is, so that we get back onto the main thread, because we are making an asynchronous call. So we want to get back onto the thread of the UI. There's only one UI thread. So this is getting us back to that thread. So now, as you can see, we have our thumbnails and all of these mini thumbnails that are being loaded, as well as some of the metadata associated to it. But we're not able to load any of our content as of yet. So the next guy that we want to update is going to be the user content. So in order to do that, we're going to get rid of all of these hard codings. All right. So this one will also inherit from base API. We're also going to do the exact same thing for initialization and the 3 necessary fields. So I'm just copying and pasting that inside. Where is it? Here it is. So we're going to make the same change we did for the other guy. We're going to make a private variable that's nullable. So it's going to be lazy. It's going to be private set. So we're going to check that it actually has something in it. And then if it does, we can just return it safely. If it doesn't, we need to initialize it. And we're going to do the same thing we did before. And then we're just going to return it. This guy needs to be cast. This guy needs to be var. And the reason for that is when you do let, obviously it's a constant. So if this hasn't run yet until it's been called, then if this was let, you would be overriding it, which is not allowed. So that's what that error was about. And then we go into our actual get content of owners call. So we're going to do really the exact same thing. We're going to add a callback. But first, let's create our URL. Whoops. it might be worth it actually to have a URL instance, but yeah, let's just continue. So user content is this guy. So we're going to put user content in here. And then in this case, if I remember correctly, I do have a payload because I'm trying to get back only the user content for these specific users, which is the users that I, as the currently logged in person, am currently following. So in order to do that, we need to add a payload. So we're going to do that. We're going to do that. And in order to do that, we need to indicate what kind of payload. So of course it's going to be JSON. So we're going to add that. And then this is going to be a post. So we're going to indicate that. And then I want to create a new object, this guy right here, that's going to wrap the IDs, the unique IDs for each owner. So in the models folder, I'm going to create this file, and I'm going to do this as a, I'm just going to copy and paste this in. Because it's trivial, it's just the ID, that's all it is. But make sure you make it encodable so that it can be converted into JSON. Decodable means decoded from JSON into a type instance. So, so that's what we're going to do here. And we're going to return that. And we're going to get the URL session again. Actually, it's an upload task. Yeah, this is the guy. Okay. The rest of it is pretty much identical. So we're going to do the same thing where we see if the data actually has anything, and then if it doesn't, we just print it out as an error. And then we exit. Whoops. Sorry. So we need to do another try. Try, catch, do catch. Because makes sense because we're not trying to do a type, we're just trying to do JSON. So that makes sense. So I'll provide another message. So then we have to do another, because we're doing an entirely separate try. Actually, let's put this in later. So again, we're getting the type, we're not getting the instance. That's why we have this here. All right, so now we can create our callback. And we're going to make this escaping as well. And it returns void. All right. So now we need to find the content area, which is this guy right here. And then we need to find the view model, not the view, because remember we set up all of our views so that they use view models and don't have actual data inside of the view itself. That is state data. So we have to go in here, and then we have to update this guy. So we have our parameter of owners being passed in. Whoops. All right, so we created this callback. Just make it nice and neat. Just make it nice and neat. And so we created this callback. And this is where we're setting our actual data, because we we're making internally an asynchronous call. And actually, I just want to make sure that, yeah, I did not call resume, so this thing would not have done anything. And then let's put the message. So we're making an asynchronous call. So that's why we needed the callback. And then once again, we're going to do this stuff right here. Just be lazy. Right? And this time the reason why, well, I mean, we're not in an initializer. So that's why we're not getting that error complaining about usage of self. And then we're going to go back, and in here, so let's see if this works. Doesn't work. Why doesn't this work? Because, let's kill this. All right, guys. So the cause of that crash is because this call that gets our content based on the owners, meaning the people we're following, is actually being called on appear. So this is my error that I did, but actually this is a good thing for you guys to see, because in this case, on appear only runs one time when this thing loads. So what we needed to do, and this is from our previous code that we had before we started integrating the Vapor backend. So what we needed to do is something like this. And I actually had this in my notes, but I totally forgot about it. But yes. So I'm sure you can easily understand what this is trying to do. We're just overloading the equal operator so that we can compare two instances of a user object and determine how we determine if they're equal or not, right? So in this case, we just want to say quite simply, well, if the ID is the same, then they're equal. So the reason why this guy needs it is because it starts with a certain value and then it emits into the closure the changed value. So it needs to be able to compare these two against each other. So that's why we had to do that. So then now if we run this, everything works, as you can see. So I do apologize for my error. That was my error, but I think you'll agree that if you weren't aware of this, it's definitely something to know. Both the action of on appear, that it really only loads one time, irrespective of how many times something, some variable inside of it might be being used or being changed. And then we had to switch to on change, which keeps track of this property over here of the view and notifies basically, or does a callback basically whenever it changes. So, and then comparing the two. So if it's been updated, but the equality hasn't changed, then it's just not going to run again. So then we could do our set content. And then once we got our content, everything else over here just started working, because obviously we had our IDs and everything to be able to find the paths to stuff. So yeah, guys, that's it. Our data is now tied to the front end from the Vapor backend, and we have the beginnings of a full stack application. So awesome. If you enjoyed the video, if it was helpful to you, like the video, subscribe if you haven't already, share the video. Thanks for watching.